note from this note that from the example we have just used now, the domain that is, I can call it dom f, that is the domain of that function, is a set of A, B, C, D. It's a set. You know, remember, we represent sets using curly brackets, braces, okay? So why the range? The range, that is Rn of f, Ren of f, is the sets that are P, okay, P, Q, R. These are the ones that are. Now, the codomain, that's everything now, is the set P, Q, R, S, T. I hope you can now see the difference. I hope you can now see the difference. You can now see the difference between the range and the codomain. So the codomain is the bigger space. It has bigger size of elements. It has more elements than the range. The range are just the elements that are mapped by the element in the domain. So that is that about that. Now let's define this. Let's define this. Another definition. Another definition here. Let M and N be two sets. Let M and N be two sets. If each element X in M, we are using X abstractly here now, there is exactly one corresponding element Y in N. There's exactly one corresponding element Y in N. Then M is mapped. Then M is mapped into N. Then by the function, let's by the function F. By the function F. Okay. Now let's use a mathematical notation to show that. We'll be using graphical illustration. Let's show this using mathematical notation. So we can have F maps M to N, or we can say F with element X to element Y. Okay. So Y, note, let me write the note there. Note, Y or F of X is called the image. It's called the image of X, or the value of the function, So how do we get F of X? The asking me, or you wanted to ask, be wondering how I got my F of X. If you look at what I've just written here, I said you can write F, just the interpretation of the graphical illustration in the earlier example, can say F maps M to N, or F takes element X to Y. You know, X is coming from, X is an arbitrary element from M, Y is an arbitrary element of N. So if you pair this together, that is F of, is a function depending on variable X. So that's why I call it F of X. So if it is an onto function, it will be equals to Y. Say F of X equals to Y. So you can write, instead of writing F of X, you can write Y. So generally speaking, F takes element X, becomes F of X equals to Y. Okay? Now, for example, let's look at this example. For example, the image of I, that is the image of I, the image of I, if f of I and the value of f, the value of f and the value of the function, and the value of the function, at x equals to a is f of a. Okay, so maybe here we have x equals to a. So, and I is the image. According to image is just elements in the codomain. Just like you are standing in front of the mirror, you see your image. So the mirror is the function. You are representing the domain. Why the image being produced is coming from your reflection. Okay, so we can have this. Let's illustrate with this. You have this m, x, and you have y here. So you can see f is the function between between x and y. We have discussed that it's not new. So the set M is the domain of f, yes, represented by df. The set M is the domain of the function, which is represented by df. Some author prefer to use d of f. It could be df like this, or d of f. Still the same thing. Now the range of f is represented by rf. You can write the range of f rf, or you can write r of f. And the range of f is always a subset of codomain, of course, because we have exhibited that before. The range is not up to the entire codomain. Now let us consider these instances. Now let M be a set of A, B, C, D, and N be a set of P, Q, R. Okay. Now note, for f taking M to N, let's note this. Let's look at this. Let's look at this graph. For x taking that to that, we have M here, we have N. Okay, this is the function in between them, which is the vehicle carrying elements from Lagos to Ibadan. Okay, now we have P, Q, R. These are places in Ibadan. So these are elements coming from, these are the passengers, they are going to different places in Ibadan. So we have A is going to Q. Let's use that the example we have here. B is going to P, and C is going to R, according to the example we have here, and D is going to Q. Yes, Q. You can see Q is mapped twice. Now this clearly suggests that f of A, that is f, is the vehicle carrying the passengers from this location, Lagos, to this location, N, Ibadan. So f of A is equals to Q, of course. F A is mapping to Q, is being mapped to Q. Then f of B is equals to P, of course. B, you can see it goes to P, fine. F of C is equals to R, C goes to R, fine. This is the function, you understand? And f of D goes to Q as well. D is also mapped to Q. A and D are mapped to Q. So the domain DF will be set A, B, C, D. Of course, the elements in M. It's not new. The range now will be P, Q, R, because these are the elements in the codomain that are that are mapped. So note that the range of f is the same as the codomain of f in this example. In this example, you can see the range of f is equally the codomain of f. So in the next video, we shall use further example to illustrate this concept. Stay blessed. God bless you.